Okay, confidential containers is what I was going to talk about from a security standpoint. So this is kind of a new thing that we may find ourselves increasingly caring about. We've talked about some other settings where we're concerned about setting up the data center so that you can be protected from some other tenant that's running on some other hardware. But one of my sort of favorite attacks against infrastructure is a supply chain attack, where you have a workflow and something that you get off a SPAC that's been modified quietly can go and notice that someplace else in the same job, somebody's running a really expensive model, and I want to grab that model and exfiltrate it to my good buddies over in North Korea or whatever. So if you have something that you want to protect even from within the same system that you're really concerned about, you have private data, PHI, whatever, you may wish to run it in sort of a secure enclave, if you will, or a trusted execution environment. So there are a number of the CPU vendors that have been having support for this, and I'll give a list of them here in a little bit. And this is something that we've been doing is as of our latest GPU, the H100, you can set that up and have a single trusted execution environment that runs between the two. So, sorry, I got these slides from somebody else, so I'm sorry about the automation here. On the left-hand side, this is sort of a stack that you have, and in confidential computing, you want everything that's on the right in red to be protected so that something else won't interfere with it. And you need to have some hardware to be able to support confidential computing, and we'll talk a little bit more about what that is. So if you basically look at infrastructure as a service and what's happening inside this, the first thing you want to do for isolation is to make it so that if you get something bad that's in there, that it can't get out to the outside world and do bad things outside of it. So that's a sort of isolation, and you can set up an isolation boundary for that. The other thing that that still allows you, though, is for some bad actor to come in and interfere with whatever it is that you have, and you want what you call for stopping that is confidentiality. So that keeps somebody else from being able to get in, look, see what you have, and mess with it. So what we have today working that you can go buy and try is confidential VMs. So that's basically generally available at this point, and that includes a firmware, driver, and remote attestation service. So those are all in place so that you can do those. But we all love containers. So how about containers? So that support is basically in a tech preview, and that's what I'm going to explain here. And special thanks to Zvonko Kaiser, who's the person who's been driving this. So first, what they are. So we use the cute term COCO for confidential containers, and that's a sandbox project in CNCF. And it enables you to have confidential computing taking advantage of these technologies that we have. And Intel has CPUs have SGX and TDX. AMD has SEV, and IBM has something called Z-Secure execution. And then you need some software to go along with those to protect the data that's in use. And so there are lots of companies that have been working on this to bring this to fruition. So the reason why, again, is that these TEEs are kind of isolated environments that let you use this hardware that you can neither access nor modify either the applications themselves or the data that's in use. So it's all encrypted, you can't see it, data doesn't come out without being encrypted and protected and so on. And we want to take that infrastructure and integrate it with the cloud native world. So the goal is to standardize this basically in a Kubernetes context and make it work there. So that basically Kubernetes users can just deploy confidential containers rather than just VMs and be able to work that just as we've done everything else. So ultimately, you shouldn't have to know or care that you're using any of the features of confidential computing while you're in it. It's just another job. It's just another container, just gets deployed and all the infrastructure is there. So the Cocoa enables you to do this, and it can be managed by a cloud provider. You can essentially just download those confidential containers from wherever. You probably care about the attribution and making sure that they're good. They may be encrypted, or they may in turn get while they're in use can be encrypted as they interact with the outside world. And the key thing that you want to make sure that you have behind the secure confidential computing is attestation. You want to make sure that the hardware is what it says it is, that all of the software that's there has been gone through a secure and measured boot, and that you're using all the stuff that you need. And I think somebody else was asking a question about whether the signing of this process and how that interacts with. I think that that was a challenge that somebody was running into with Red Hat, where they had to have more pieces of the infrastructure signed, and there were some interactions there. So some challenges in deploying it. So we want to make this simple and stable and driven by the use cases. We want to make sure that this is part of the standard CI/CD, et cetera, for all the features that we have for this. So the key technology that's behind this is Kata containers. So then and Cocoa is kind of this umbrella that includes Kata containers, and then other guest components like attestation and the data hub. The confidential data hub, or CDH, is a guest service that has the resource-related APIs that include a key broker service, sealed Kubernetes secrets, and a secure storage for being able to do that. And so the CPU has to have the support for confidential computing. By the way, Grace does not. ARM does not, because it's an ARM, and ARM does not yet. But that's coming in the next generation of ARM. Among the things that you need to do that you may care about is that you may have data that's being used with a model, and those could be different owners, and they separately need to be encrypted and have their attestation managed, and you're managing this attestation across different devices like the CPU and GPU. So you need some software infrastructure to be able to make all that work and come together. Zvonko has put all this together. He's done some custom builds of the OVMF and the QEMU and the guest and host kernels. He's made some requests, a KEP for the CRA API. You want to make sure in this environment that you can't do hot plug. That would would compromise the security. And so that's something that remains to be done with this. But he's set up something that is working and is available as a tech preview, and that's on its way to GA. So the call to action here is, you may have an interest in just trying out confidential computing, seeing what that looks like. You can try that with confidential VMs today. And then as Cocoa becomes available through this tech preview, you can try that out yourself. We're expecting that these kinds of environments are ones that we'll all have to deal with and test, and they're going to be part of systems that we're going to deploy on. And we want to make sure that we're streamlining the use of containers and kind of poking at the edges of the rest of the ecosystem for what it's going to take to support that. So it's on its way. So that's it.